Welcome back, fellow math enthusiasts, to another mind-bending journey through the fascinating world of limits. In this video, we are going to crack open the enigma of irrational function with a single captivating problem. Forget everything you thought you knew about limits, because today we are going to challenge your mathematical intuition and uncover the mesmerizing intricacies that lies in these mysterious functions. So grab your pen, paper, and your curiosity, because you just signed up for an amazing mathematical adventure. Let's get started. We want to find or evaluate the limit of the ln of cos x, all divided by the 4 root of 1 plus x squared minus 1. So let's begin. We will use a particular property. Firstly, we will use this property that says that the limit of the ln of 1 plus f of x, all divided by f of x, as x approaches 0 equals to 1. We want to use this property. So in order to use this property, we must have 1 plus f of x as the argument of the natural log. And how do we do that? We already have a cos of x here. So we can add 1 and subtract 1. Therefore, this will be written as the limit as x approaches 0 of the ln of, this will be 1 plus cos x minus 1. This positive 1 and this negative 1 cancel out. We are still left with cos x. And all divided by the 4 root of 1 plus x squared minus 1. So at this junction, we will separate the limits into 2. We'll have the limit as x approaches 0, the ln of 1 plus cos x minus 1, and then multiply by the limit of 1 over the 4 root of 1 plus x squared minus 1 as x approaches 0. Now, after writing this, the next thing we want to do is to have 1 plus, remember, it's 1 plus a function. So in this case, the function will be cos x minus 1. So we want to ensure that this exact same cos x minus 1 is in the denominator of this. So we want to write this so that I can resemble this particular identity. So let's see what we have. We have the limit of the ln of 1 plus cos x minus 1, x approaches 0. We must multiply this by, because this is a function of cos x minus 1. So we multiply by cos x minus 1 and divide by cos x minus 1. Now, this will be multiplied by the limit of 1 over the 4 root of 1 plus x squared minus 1 as x approaches 0. Great. So what do? We take this and insert it under this ln. So we have the limit of the ln of 1 plus cos x minus 1, which is the function f of x here, all divided by, so this is going to go under this cos x minus 1, and then x approaches 0, times, remember we have one factor still up here, so it's cos x minus 1 up there, multiplied by 1 over the 4 root of 1 plus x squared minus 1. Now, we can evaluate this as a single limit. So this entire result gives us 1. Remember, we are still taking the limit of these other expressions. So this entire thing is 1. So we just have, and 1 times the entire thing is just 1. So we just have the limit of cos x minus 1 times 1 over the 4 root of 1 plus x squared minus 1 as x approaches 0. Now at this junction, we can factor out a negative from right here. So we have the limit of negative 1, parenthesis over here. This becomes positive, And this cos x becomes negative minus cos x as x approaches 0, and then times 1 over the 4 root of 1 plus s squared minus 1. Now at this junction, we're about to do two rationalization. Here we have 1 minus cos of x. So we want to rationalize this, and here we also want to rationalize. So this negative goes behind the limit sign. We just have the limit of 1 minus cos x. We multiply by the conjugate, which is 1 plus cos x, all divided by 1 plus cos x. Great. Once we rationalize 1 minus cos of x as 1 plus cos x divided by 1 plus cos x, we keep this constant and then simplify from here. Great. After doing that, we can multiply. So we have 1 minus cos x times 1 plus cos x. That's our normal stuff. So we will have minus the limit. So 1 times 1 is 1. Negative cos x times positive cos of x is minus cos square x. And then it is divided by 1 plus cos x as x approaches 0. Great. This is multiplied by 1 over the 4 root of 1 plus s squared minus 1. From our trigonometry identities, we know that 1 minus cos square x is sin square x. So we have minus the limit of sin square x, all divided by 1 plus cos of x as x approaches 0. Now how do we rationalize the 4 root? We have 1 over the 4 root of 1 plus s squared minus 1. So keep this and see what happens. Now remember, we can evaluate this limit from the denominator. 1 plus cos x can be evaluated. It doesn't affect the limit. So we evaluate this and then we keep the remaining ones. So we have minus the limit of sin square x, all divided by, this becomes 1 plus cos of 0 is 1. So this becomes 1 plus 1 as x approaches 0 times 1 over the 4 root of 1 plus s squared minus 1. So 1 plus 1 is 2, and this 2 goes behind the limit sign. Minus 1 over 2, the limit of sin square x approaches 0, times 1 over the 4 root of 1 plus s squared minus 1. Great. So we can rationalize this at this moment. And to rationalize this, we should note, anytime we have a to the 4th minus b to the 4th, the factor for this is a plus b times a minus b times a squared plus b squared. So to find the rationalization for this, we must multiply by a plus b times a squared plus b squared. Because this times this gives us this. So this is like a minus b. So to rationalize this, we have minus 1 over 2, the limit as x approaches 0 of sin square x times 1 over the 4 root of 1 plus s squared minus 1. So multiply this by the numerator, a plus b. So it's the 4 root of 1 plus s squared plus 1. Considering a to be this and b to be 1. And then multiply a plus b times a squared plus b squared. So what is a squared? A squared, then you have the 4 root of 1 plus s squared all squared. And then plus b squared is 1 squared. And 1 squared is 1. And divided by the same expression, the 4 root of 1 plus s squared plus 1 times the 4 root of 1 plus s squared plus 1. Great. So we have minus 1 over 2, the limit as x approaches 0 of sin square x multiplied by this entire expression up here is the 4 root of 1 plus s squared plus 1 times the 4 root of 1 plus s squared all squared plus 1. Once we are done with this rationalization, The next thing to do on here is to multiply the 4 root of 1 plus x squared minus 1 times the 4 root of 1 plus x squared plus 1. This is going to give you the square root of 1 plus x squared and then minus 1. That's what this is going to give you. Because this times this is the 4 root of 1 plus x squared all squared. So this square is going to affect this 4 root, which is going to become square root. So this is going to be, this times this is going to be this. And then we multiply it by, it will simplify the 4 root of 1 plus x squared all squared. We are going to have the square root of 1 plus x squared, and then this is plus 1. So we'll have minus 1 over 2, the limit of sin square x. Remember, we can rewrite this, the 4 root of 1 plus x squared plus 1 times the 4 root of 1 plus x squared all squared plus 1 all divided by, if we multiply the square root of 1 plus x squared times the square root of 1 plus x squared is just 1 plus x squared, because the square root will cancel out. And then minus 1 times positive 1 is minus 1. The next thing to do is to write the limit of sin square x. Now this positive 1 is going to cancel out this negative 1. So you're just going to have an x squared on here, over x squared as x approaches 0. And for this, we have the limit of the entire expression, the 4 root of 1 plus x squared plus 1. And then we can simplify it. This 2 goes into this 4 2 times. So it is square root of 1 plus x squared plus 1. Great. At the end of the day, we can do direct substitution. So we have minus 1 over 2. We know this can be written as the limit of sin x over x as x approaches 0 all square. This square is going to affect both this sin and this x. And then for here, we apply direct substitution. We have the 4 root of 1 plus 0 squared plus 1 times the 4 root of 1 plus 0 squared plus 1. The limit of sin x over x as x approaches 0 is just 1. So this entire thing is 1. So we have minus 1 over 2 times 1 squared multiplied by the 4 root of 1 is just 1. So it is 1 plus 1. And then the 4 root of 1 is 1, 2, 1 plus 1. So we have minus 1 over 2 times, this is 2 and this is 2. So 2 times 2 gives us 4. Negative half of 4 is just negative 2. So this negative 2 is the answer to the limit of the ln of cos x, or divided by the 4 root of 1 plus x squared minus 1 as x approaches 0. So remember that we could use L'Hospital rule to evaluate this limit, but we want to use a method other than L'Hospital rule, because we assume that those that are watching this video do not understand derivative of natural logarithm function, do not understand derivative of trigonometric function, do not understand derivative of functions of these kinds. So we use a method that involves L'Hospital rule. Please subscribe to our YouTube channel, follow us on Facebook. Thank you for watching, and we hope to see you another time.